Hi, my name is Hazel Rivera. I am come from the University of Puerto Rico at Mayagüez. I am currently studying mechanical engineering and I will be graduating in May 2018. This summer, I participated in the Summer Undergraduate Research at Florida, the SURF program, as part of the Applied Physics Research Group of the Mechanical and Aerospace Engineering Department. The project I worked on this summer was water purification with plasma reactors. My mentors were Dr. Subrata Roy and Baswati Chaudhary. First, we need to understand what plasma is. Plasma is considered the fourth state of matter. It is ionized gas that consists of positive ions and free electrons, totaling to an overall null electric charge. It is the most abundant state of matter in the universe and can be found in stars, fluorescent lamps, and lightning. There are many ways to generate plasma artificially. One of these is the surface dielectric barrier discharge plasma. It entails the formation of an electrical charge between two electrodes separated by a dielectric material. These reactors or actuators are composed of two things: the circuit to power the electrodes and the dielectric material with the desired configuration of copper electrodes. The circuits for the actuators have many components such as inductors, capacitors, and resistors. These need to be soldered on the surface of printed circuit boards for them to achieve the required specifications to power the electrodes. To print the electrode configuration on the surface of the dielectric material, we use a process called photolithography. It is a method of using light to transfer a pattern. The mask has the desired pattern we want to print on the material. The photoresist is a light-sensitive chemical that will transfer the geometry. Then, the mask and the resist are both exposed to UV light to print the pattern on the substrate of the dielectric material. Then, sodium carbonate and ferrochloride take part in the etching process to remove the material not printed. After that, the material is dipped in acetone and tin to avoid rusting of the copper electrodes and allow attachment of the solder. After soldering the circuit components, tuning it to the right frequency, and making the actuators to photolithography, everything comes together to power up the actuators in order to achieve plasma generation, which can be observed by the bluish glow on the electrodes. Plasma actuators have many applications, such as flow control and air and water purification. When plasma is generated, the oxygen molecules in air split into single atoms, which then recombine with other oxygen molecules to form ozone. Contaminated water contains bacteria. A method of purifying it is the ozonation process, which destroys the bacterial cell wall, therefore killing the organisms. In order to have an effective killing of bacteria, we need to mix the ozone properly into the water. To do this, we employed the use of a suction pump diffuser, which through a series of aspiration ports suctions air into the passing fluid. This design was based on a patent by Dr. Roy. It was then created into a 3D printed model. Computational fluid dynamics analysis were conducted on ANSYS Fluent to better observe the behavior of the flow passing through the diffuser. Ozone tests were done on samples of purified water by ozonation to measure the amount of ozone being mixed into the water. Applying for graduate school is not an easy process. Thankfully, the SURF program provided us with tools and information to help us along the journey. We were able to take GRE sessions and seminars on various topics such as literature review, fellowships and grants, and forums with current PhD students. Of course, not everything can always be work. We were able to visit many places in Florida, such as San Agustin Beach and the Kennedy Space Center. Being here at the University of Florida has been an amazing experience. I have learned so many things that will help me in the future, such as research experience, engineering skills, and many more abilities that are important in any professional scenario. I would like to thank the University of Florida, the Office of the Provost, Mike Nazareth, Julissa Nunez, my mentors Dr. Roy and Baswati, and the whole APRG lab. Thanks for watching.